Sodium hydroxide pellets, when you talk about pellets, you're talking about small pieces, they are in the shape of a pill, So, but now we call them pellets. And they are added to the 500 cubic centimeter of sulfuric acid solution. Remember, that is what was definitely given to you. The balanced equation for the reaction is as follows. Can you see? We have 1:2, and then there the salt that is being formed is 1, and the water there is 2. And then after completion of the reaction, the pH of the solution was found to be 1.3. Assume complete ionization of H2SO4. One of the properties of strong acids is that it is able to dissociate completely into ions, and sulfuric acid is one of those strong acids. So that's why we have a complete ionization. And when you talk about complete ionization, then you are saying we have H2SO4 and you have 2H plus SO4 2 minus. That's what we mean by complete ionization. Okay, so now what is it that we are talking about here? The main thing that we need to do is to calculate the mass of sodium hydroxide added to sulfuric acid solution. Assume that the volume of the solution does not change. Remember, the volume that was given was 500 cubic centimeters. Right? Now, what is it that we need to do? We need to use the given information in order for us to get to finding the mass of sodium hydroxide. And what is it that we can use? We can make use of this pH that is given. And going to the information sheet, you definitely have something that has to do with pH. And remember how to get that? pH is minus log, and that is the concentration of H plus ions. Remember, a square bracket is there to indicate concentration. Now, the minute you put a value, you are not going to put a value there and then say you have 0.1 like that. No, you can't say concentration while again you put the value there. So when you have the value been written already, don't put the square bracket. Okay, now what we don't have here is not necessarily the pH, but you are given the pH. What you don't have is the concentration of the H plus ions. So that is what we are trying to find here. So pH has been given, and I think that is 1,3. 1,3 is equal to minus log, that is the concentration of the H plus ions, which means if you do that anti-log H or the exponential part now, we find that we are going to have H plus, it's just the same as 10 to power minus 1,3 if you want to do it the other way. So mathematically, that's what we have. And if you do that, then you're going to get your answer as 0.05. And this is concentration, moles per cubic decimeters. Now, this is going to help us in finding the concentration of H2SO4. So therefore, the concentration of H2SO4 will therefore be half of this, because the ratio, remember, is 2:1, right? What I'm saying is we had, let me go back to what I had. This is 1 and this is 2. So therefore, in this case, if the concentration of this one is 0.05 and this is X, then X cross multiplication is 2X is equal to 0.05 multiplied by 1. So X is equal to half of this, all right? So that is how we get the concentration of H2SO4, right? So half multiplied by 0,05 over 1, right? And when you do that, you are going to get 0,012, not, is it 125? 25, not 125, but 0,025. This is still concentration, moles per cubic decimeters, right? So this is very important. Why do we have to do this? Is because we need to find the number of moles of sulfuric acid. So if you've got concentration, now we can use that other one of N is equal to CV. And that is what we are going to do. So therefore, number of moles of H2SO4 is going to be CV, and you just found the C, 0,025. The volume, remember, it was 500 cubic centimeters. And do not forget that this is in cubic decimeters, which means even that concentration, volume, needs to be in cubic decimeters. So you divide by 1,000, then you get that as 0,5. When you multiply, then you get 0,0125, isn't it? 125. 5 by 5 is 25, carry 2, 12 carry 1. That's it, right? And then you've got MOL there. So this is number of moles of sulfuric acid. And this was the one that was in excess, the one that reacted with sodium hydroxide, okay? Right, and now what we want to find is the ones that reacted. So therefore, N of H2SO4 that reacted will be equal to what? We take, remember at the beginning, you were asked to find that. We found that 0,075. Okay, so we are going to use 0,075 minus 0,0125. And when you do that, we get 0,0625. These are the number of moles, all right? And why do we have to do this? Is because we are striving to go for that section where you are using that relationship from the balanced equation. Remember, we've got NaOH, we've got H2SO4. And according to the balanced equation, let's go back quickly. We've got 1:2. So we've got there 2 here, and you've got 1 there. And we have just found that H2SO4 is 0,0625. 0,0625 is to X. So X will be equal to 2 multiplied by 0,0625. And when you multiply that by 2, what do you get? 0,125. So therefore, N for NaOH will be 0,125. There you go, guys. And what was the question about? It was not about number of moles, but it was about mass. Then M, we know if we have N is equal to M over M. Now this is for sodium hydroxide, isn't it? Then we are going to substitute that 0,125 is equal to the unknown M that we are looking for. And sodium hydroxide, the molar mass thereof is 40. So that when you have your M there, you multiply 40 by 0,125. 125, and you are going to get 125 multiplied by 40. And what do we get? You get 5 grams. There you go, girls. Now you are having your answer, and this is what was needed. So basically, guys, when it comes to stoichiometry, the most important thing is that you always use the given information, and you try by all means to get number of moles, so that ultimately you come and find that relationship from the balanced equation, and you use the information that you have accumulated against what you are looking for. So you are going to use that so that at the end you get the number of moles, and then from there you proceed and find whatever you are looking for.